Hello students, welcome to the class. So in the last class we have started with the physical world, units and measurement, right? So today let us continue with the next point. In the last class we discussed about what are the different types of units, then dimension formula, principle of homogeneity, how to calculate the units, how to calculate the dimensions of a given physical quantity. Okay, these all points we have completed in the last class. We discussed about physical quantity, how this physical quantity can be divided into two types. That also we have discussed in the last class, right? So today let us continue with the next point here. The next point is there are two basic quests in physics, that is unification and reduction. So let us see what do you mean by unification and reduction. See here, one large question about scientific theories that exist philosophically and scientific attention. It concerns the possibility of producing a single theory that will encompass the domains of all the sciences. So here in science we will come across, means in science, or you can take in physics, we come across many laws here, we come across many laws here. So here all the laws, it is not that directly we will observe the phenomena and we will give some laws here. Okay, it is not copied by some other thing also. So here unification and reduction is one of the method for existence of laws in the universe. That is, many thinkers are attracted by the idea of a unified science, or by the view that the sciences form a hierarchy. Okay, chemical reactions themselves involve the forming and breaking of bonds, and these are matters of microphysics. So as we know that whatever the chemical reactions are there, in that whatever the breaking and forming of the bonds takes place, it is nothing but it is a microphysics. A complete account of those ultimate constituents and their interactions would thus amount to a theory of everything. Okay, it leads to what? Theory of everything here. That is what unification, that is what unification. So unification in the sense it is combining, unification in the sense it is combining, means whatever the small contents we will be knowing, so combining that and giving, that is called as unification. Reductionism is what? Reductionism is a philosophical position which holds that a complex system is nothing but the sum of its parts, and that an account of it can be reduced to accounts of individual constituents. This can be said of objects, phenomena, explanations, theories, and meanings. Okay, so here this reductionism is what? It is nothing but the sum of its parts, and that an account of it can be reduced to accounts of individual constituents. So unification combining, reduction is reducing, means dividing the content into objects, phenomena, explanation, theories, and the meaning. So this is nothing but that is unification and reductionism in physics. Okay, so whatever the electromagnetic theory, whatever the theories we come across, that is all based on unification and reductionism, right? So any law, either it is a product of unification or it is a product of reductionism. Sorry, next one. Conservation laws. So what do you mean by conservation laws here? See here, that is, conservation of laws means here we come across many laws like conservation of mass, conservation of energy, conservation of linear momentum, conservation of angular momentum, conservation of energy. So what do you mean by conservation here? Conservation in the sense the quantity remains constant. The quantity remains constant is called as what? Conservation. So here conservation examples are many examples. We have conservation of energy, conservation of linear momentum, conservation of angular momentum, conservation of mass, conservation of charge. So what do you mean by this? Let us see. Conservation of energy implies that energy can be neither be created nor be destroyed, although it can be changed from one form into another. So here conservation of energy is nothing but what? It is the conversion of, it is the conversion of one form of energy into the other form of energy is called as conservation, is called as conservation. Okay, here energy neither be created nor be destroyed, it can only be transferred from one form to other form, that is conservation, means it remains constant. Okay, for example, the mechanical energy is converted into kinetic and potential energy, means if the water is stored, that possesses potential energy. When the water starts flowing, it possesses kinetic energy. That is, conversion of one energy into another energy is called as what? Conservation of energy. Means here the loss of energy does not takes place. You may feel that there is a loss of energy, but here what happens? The energy is getting transferred from one form to the other form. Next, that is chemical energy, kinetic energy, etc. into another. In an isolated system in the sense, students, here, that is, there is no any external force is acting. There is no any external forces acting, that is called as what? Insulated system. In that, the sum of all the forms of energy therefore remains constant. For example, a falling body has a constant amount of energy. Okay, so whatever the falling body is there, it is having the constant amount of energy, but the form of the energy changes from potential to kinetic. So according to the theory of relativity, energy and mass are equivalent. So what we say here, when a body is falling from a certain height, here the energy is remaining constant. Okay, it only changes from what? Potential energy to kinetic energy. So this is nothing but what? It is related to our energy and mass equivalent, that is according to Einstein, E is equal to mc square. Thus the rest mass of a body may be considered a form of potential energy, and part of which can be converted into other forms of energy. It can be converted into other forms of energy, right? So this is regarding what? Law of conservation of energy. Then next, here you can see the fundamental principles are like a conservation of momentum. Fundamental principle, we can take conservation of energy, conservation of angular momentum. These three are what? Fundamental principles. Okay, so here this is related to, see that conservation of energy is giving the mass energy relation, that is Einstein's equivalent. Then mechanical problem solving, a powerful tool for mechanical problem solving. Then with external forces, that is work energy principle. Next, role as a fundamental principle. They show up in many forms in its. Okay. Then next we have one more conservation on law, that is law of conservation of linear momentum. Conservation of linear momentum expresses the fact that a body or a system of bodies in motion retains its total momentum, that is the product of mass and velocity vector. Okay, so linear momentum is what? It is the product of mass and velocity. Okay, unless and until any external force is applied to it in an isolated system, there are no external forces, so momentum is always conserved. So what we say, if there is no any external forces acting, then we can say that the momentum is what? Conserved here. Because momentum is conserved, its components in any direction will also be conserved. That is the application of the law of conservation of momentum. That is application of law of conservation of momentum here. It is important in the solution of collision problems. The operation of rockets exemplifies the conservation of momentum. The increased forward momentum of the rocket is equal but opposite in sign to the momentum of the ejected exhaust gases. So here conservation of linear momentum is applicable for the rocket propulsion. It is applicable for the rocket propulsion. Okay. So whatever the conservation laws we are studying, these are applicable. These are what? Applicable for one or the other phenomena in the nature. Okay. Next, we have conservation of mass. So we discussed conservation of linear momentum, then conservation of an energy. Then next we have conservation of mass. So only the thing is what? The quantity remains constant, that we need to remember. Conservation of mass implies that matter can be neither created nor destroyed. That is, possesses that change the physical or chemical properties of substances within an isolated system, such as conservation of a liquid to a gas. It leaves the total mass unchanged. So strictly speaking, that is, mass is not a conserved quantity. Mass is not a conserved quantity. However, except in nuclear reactions, the conservation of rest mass into other form of mass energy is so small that to a high degree of precision, rest mass may be thought of as conserved. So here what they will say, here conservation of mass is what, neither be created nor be destroyed. But if you see the nuclear reactions, their masses are getting converted. So there what happens here, mass energy relation come to the picture. That is, mass, whatever the conversion takes place, that is released in the form of what, energy. That is released in the form of energy. Okay, that is conservation of mass. Then next we have conservation of charge. Conservation of charge states that the total amount of electric charge in a system, it does not change with time. Here conservation of charge says that the total amount of electric energy in a system, it does not change with time. At a subatomic level, charged particles can be created but always in a pair with equal positive and negative charges, so that the total amount of charge always remains what, constant. So conservation of charge, what it states, it states that the total amount of electric charge in a system, it does not change with time. It does not change with time. Here at a subatomic level, charged particles can be created but always in a pairs with equal positive and negative charge, so that the total amount of charge always remains constant. Getting? So this is what conservation of charge. In particle physics, other conservation laws apply to certain properties of nuclear particles, such as boron number, lepton number, and strangeness. Such laws apply in addition to those of mass, energy, and momentum, which encountered in everyday life and may be thought of as analogous to the conservation of electric charge. Okay, so this is regarding the conservation of laws. So in a given question, if means mark the conservation law among the given following, means we have conservation of charge, linear momentum, angular momentum, mass, energy. So like this we need to remember. Then next we have the uses of dimensional analysis. Already we discussed what do you mean by dimension, how to write the dimensions of different physical quantities. Let us see the uses of this dimensional analysis. See here, there are three main uses of the dimensional analysis. First one, to convert a unit of given physical quantities from one system of units to another system which we use. So the first one is what we can convert. We can convert one system into another system. We can convert a unit of given physical quantities from one system of units to the other system of units. Right? So that is formula we have, that is N2 is equal to N1 into bracket M1 by M2 into A, sorry, to the power of A, then into L1 by L2 to the power of B, then next T1 by T2 to the power of C. I'll just show you how it is exactly. Means here, if you know the unit of one quantity in one system, we can convert it into other system. So here we have the formula, that is N2 is equal to N1 into bracket M1 by M2 to the power of A. Then next L1 by L2 to the power of B. Then next we have T1 by T2 to the power of C, to the power of C here. That is what, this is the formula which is used to convert a unit of a given physical quantities from one system of units to another system of unit. Okay, suppose if I give you the unit in the SI system, you can convert this SI system into CGS system also, you can convert it into some other system also. Like this, the conversion we can do by using dimensional analysis, here. Then next one, to check the correctness of a given physical quantity, means suppose if you have some equation, that is you can take a equation, centripetal force is equal to V square divided by, so centripetal force is given by m v square into m divided by r, or m v square by r here. That is the expression for what? Centripetal force. So what is the, we can check the correctness of a given equation. Suppose this is the given equation. Instead of this, if I take it as f is equal to m square into v divided by r. Suppose if the question is given like this, here you can check the dimensional formula for force is what? ml t raised to minus 2 into, this is m raised to 2 into velocity is L t raised to minus 1 divided by it is L, which is equal to m raised to 2 L raised to 0 t raised to minus 1. You can see here the RHS and LHS terms are not equal, which means that the given equation is not correct. Suppose if I take f is equal to, suppose if I take the correct equation, that is f is equal to m v square divided by r. Now check the correct dimensional equation. ml t raised to minus 2 is equal to m into L t raised to minus 1 to the power of 2 whole divided by it is L. That is equal to m L raised to 2 t raised to minus 2, and in the denominator L is there, that it becomes L raised to minus 1. That is nothing but m L raised to 1 t raised to minus 2. Now you can see the LHS is equal to what? RHS, which means that dimensionally the given equation is correct. Dimensionally the given equation is correct. So first application is what? You can say it as application or uses also. The first application is you can convert from one unit to the other unit, or next what you can do, you can you can check the correctness of the given equation. If both RHS and LHS are equal in dimensionally, then we can say that the given equation is correct. Then we can say that the given equation is correct. Okay. Then next, third point, that is to derive the relation between different physical quantities. So by using this, we can derive the relation between different physical quantities. Like suppose if the unit is given as 1 Newton, we can convert Newton into CGS unit of dyne. So 1 Newton is equal to, we say that 10 raised to 5 dyne. This conversion we can do by using dimensional analysis. We can also convert 1 joule into 10 raised to 7 erg. So here many conversions we can do by using dimensional analysis. Okay. So whatever this first formula is there, no, we can use that, and we can convert from one unit to other unit, and we can derive the relation between different physical quantities also. Okay, so that is one there, that is one thing. And one more thing what we can derive is, suppose if the question is given like derive the expression by using dimensional analysis method, the time period of a simple pendulum. So the time period of a simple pendulum is given by 2 pi root of L by G. Such equations, not only this, many equations we can derive by using dimensional analysis method. Is it clear, students? So this is how we can do the application of dimensional analysis. We can convert unit from one system to other system. We can check the correctness of the equation. We can derive the relation between different physical quantities. Then next, advantages of dimensional analysis. So advantages and uses, they are little bit same only. See here, that is dimensional equations are used to validate the correctness of a physical equation. Dimensional equations are used to validate the correctness of a physical equation. That is nothing but to check the correctness of equation. Second point, dimensional equations are used to derive correct relationship between different physical quantities. So this physical dimensional equations are used to derive the correct relationship between different physical quantities, right? Means that is like a relation between time and length, the relationship between mass and velocity. So such relations we can derive by using dimensional equation. Then the third point is dimensional equations are used to convert one system of unit to other system. So just now we saw uses and application, advantages, application, all are same only. Then the last point is dimensional equations are used to find the dimension of a physical constant. It is used to find the dimension of a physical constant. In the sense, we can take one example. That is, suppose if I take the equation f is equal to g into bracket m1 into m2 divided by r square. Here you can see g is what? It is a universal constant. They are saying that we can calculate the dimensional formula for such constant also. How we can do this? G, I can keep it as it is. It becomes fr square divided by m1 into m2. Write the dimensional formula. It is m l t raised to minus 2. R is l raised to 2 divided by m is again 2. This is what g is equal to. So simplify, it becomes m raised to minus 1, l raised to 3, t raised to minus 2 is the dimensional formula of this constant. So any constant we can calculate the dimensional formula. Okay, so this is what advantages of a dimensional analysis. Right, next. Limitations of dimensional analysis. So limitations are very important here. So what are the limitations? See, that is, dimensional analysis has no information on dimensional constant. Means here, by using dimensional analysis, whatever the constants are there, like for example, if we have equation kinetic energy is equal to half mv square. So the dimension of 1 by 2 or any numerical number we don't have. We don't have the dimension formula for such numbers. So this is one drawback or limitation of dimension analysis. Second one, if a quantity is dependent on trigonometric or exponential functions, this method cannot be used. Suppose if any equation is there which consists of sine theta, cos theta, tan theta, or e to the power of something, we cannot use this dimensional analysis method as those quantities don't have any dimensions, right? So solving such equations by using dimensional analysis, it is difficult. In some cases, it is difficult to guess the factors while deriving the relation connecting two or more physical quantities. So in some cases, if suppose if you take any equation which is having dimensional formula, both are same. Okay, like work and energy is having same. Suppose if you want to derive such relations, it is difficult. Why? Because both the quantities are having the same dimension. In the sense, it will be difficult to do such calculation. So this method cannot be used in an equation connecting two or more variable with same dimensions. So just now I told you, that is, this method we cannot use it for the equations which contains same dimensions. Okay, suppose if I write dimension like m l raised to 2 t raised to minus 2. So here energy and work are having the same dimension. Then it is difficult to identify whether it is energy time term or it is a work term. Okay, it cannot be used if the physical quantity is dependent on more than 3 unknown variables. Then next here, the next point is what? It cannot be used for the physical quantities which is dependent on more than 3 unknown variables. So if you are solving the problem by using dimensional analysis method, there should be only one unknown term. There should not be any 2, 3 unknown terms. Okay, more than 3 if it is there, then it is difficult to do it. This method cannot be used if the physical quantity contains more than one term, that is like sum or differences of two terms. Here means if the equations are in multiplication and division, directly we can use the dimensional analysis method. If the equations are in the addition and subtraction method, then it is very difficult to use the dimensional analysis method. Is it clear, students? So this is regarding the uses, applications, advantages, and limitations, or we can say the disadvantages of dimensional analysis. Then the next point is significant figures. See here, that is for counting of the significant figure rule are as all non-zero digits are significant figures. So here we have the rules. So with the according to the rule, we can take some examples also. Okay, so for counting of the significant figures, there are some rules. Means suppose if I give you number like 4226, how many significant figures are there? How to do this? Here, significant figures are following some rules here. Those are, the first one is all non-zero digits are significant figures, which means that for example, if there is a number like 2526, you can see these are all non-zero numbers. Non-zero in the sense there is no zero in between the given number. So in such a case, here, the all the non-zeros digits are significant figures. Means here this is first, second, third, fourth. Here whatever the numbers are there, all are considered as what? Significant figure. Therefore, in the given number, the significant figures are 4, which means that suppose if it is like this, then here there is some other rule. Okay, so when the number is 2526, or if I write 25,263, here the significant figures are 5. Suppose if I write the number like okay, here 1, 2, 3, 4, 5, 6, 7. 7 is the significant figure. Significant figure is nothing but what? Here the number of digits, how many it is are there. For that we have particular rules. In that, the first rule is what? All non-zero digits are significant figures, which means that if the number consisting of, it does not consist of any zeros, then all are considered as significant figure. The next point, all zeros between two non-zero digits are significant figures. The meaning is, so according to the line statement, if you see the examples, then you will understand clearly. What do you mean by this? All zeros between two non-zero digits are significant figures. Like, suppose this is the number. You can see here, the non-zero numbers are there at the end, that is 1 and 1, and in between we have zeros. In such a case, all are considered as what? Significant figures. This is 2 plus 2, 4. This is 1, that is 5. Like this we will write the what we can say, that is significant figures. I can take one more example, 25605. So significant figures are 2, 4, 5, that is 5. If I write 256008001 2, 3, 4, 5, 6, 7, 8, 9, 10. So the significant figures are 10. So for significant figures, there is no restriction that it should be below 10, it should be below 5. It is not like that. We can write any number, how many digits are there. Okay. So the first rule is what? Here all the non-zero numbers are considered as what? Significant figures. Second rule is what? In between the non-zero numbers, whatever the zeros are also there, that is also taken as what? Significant figure. Then the third point is what? All zeros to the right of a non-zero digit but to the left of an understood decimal point are not significant figures. So this is related to the decimal point here, but such zeros are significant if they come from a measurement. So what is this? See, all zeros to the right of a non-zero. Okay, so there is a number, there are some numbers to the right of that, but to the left of an understood decimal point, there is a decimal point, are not significant. They are not considered as the significant figures. The zeros are not taken as significant figures. Okay, so for this also, let us see the example. Example for this third law, third point, that is all zeros to the right of a non-zero digit, but to the left of the understood decimal part are not significant figures. Means, for example, here we can take, that is, suppose if we have a number 0.04. So how many significant figures are there in this? We have only one significant figure. So if you have 0004, then here also it is 1. If I have a number like this, then the number of significant figure is 2. Suppose if I have a number 0.0456, then the number of significant figures are 3 here. Suppose if the number is something like this, then the number of significant figures are here 5. So that is the meaning of third point, that is all zeros to the right. You can see here these are the zeros to the right of a non-zero digit, but to the left of a decimal point are not significant. So only these are considered as a significant figures. This is regarding the third point. Then the fourth point is all zeros to the right of a non-zero, all zeros to the right of a non-zero digit are not, but to the left of a decimal point are significant. Okay, so non-zero right of a decimal point and to the left of a non-zero digits are not significant. Means here, for example, to the right of a decimal point are significant. That is, here if we have a number 0.20 is equal to, so here the number of significant figures are 2. Suppose if I have a number like this, here the significant figures are 3. Suppose if you have a number like this, then here the significant figures are 4. So these are what? All zeros to the right of a decimal point are significant. Means immediately after the decimal point, whatever the numbers are there, they are taken as what? Significant figures. Then the next point, all zeros to the right of a decimal point. Okay, but to the left of a non-zero digit are not significant. Means single zero conveniently placed to the left of the decimal point is not significant. Then the last point is the number of significant figures does not depend on the system of units. It does not depend on the system of units. Means here whatever may be the system of units, the number of significant figures, whatever the rules we are following, this rules will be same itself. Is it clear? So this is regarding the significant figure. Next point we have, that is accuracy and precision. So what do you mean by accuracy? What do you mean by precision? What is the difference between that? Let us see with the example. See one figure you can see here, the accuracy and precision. That is, accuracy is defined as the accuracy of a measurement is its relation to the true nominal or accepted value. It is sometimes expressed as a percentage deviation from the known value. Okay, the known or a true value is often based upon reproducible measurement. Means one simple example I'll take. Suppose if we do some measurement or if we do some experiments, whatever the readings we are getting here, so that is what? Close to the standard value. For example, if we are calculating acceleration due to gravity in the experiment, then in that experiment, suppose if we are getting the values like 9.87, 9.89, 9.78. So these are what? These are called as what? Accuracy. So precision is what? A measure of how close a series. Means here the difference between The standard value and the measured value is taken as what? It is taken as precision. It is taken as precision. So that is the difference between accuracy and precision. You can see in the first figure and the second figure. Exactly the same, it is accuracy. So close to the standard value, that is called as what? Precision. Okay. Means here 9.8 is what? Accuracy. So 9.87, 9.78, 9.79, what you are getting, that is precision here. Is it clear? This is regarding the accuracy and precision. Then the next part of the chapter is, that is errors in a measurement. So what are the errors in a measurement? Errors in a measurements are what? See here, that is random error. In errors, we have types. First type error. First, well, let us see what do you mean by error here. Error is nothing but what? Error is defined as, it is the difference between the standard value and the calculated value. Means in a, while doing the experiment, whatever the standard values are there and whatever your calculated values are there, so the difference between them, we take it as what? Error here. That difference is taken as error. Then in error, we have the types like, first one we have random error. What do you mean by random error? Any factors that randomly affect measurement of the variable across the sample is called as what? Random error. Random error is what? These are error factors that randomly affect measurement of the variable across the sample. Means it is not having any particular way to affect the reading. Okay, so it may be a random, sometimes it may be a positive error, sometimes it may be a negative error. Such errors are taken as what? Random error. For instance, each person's mood can inflate or deflate performance on an occasion. This is what? Random error. Then random error adds variability to the data, but goes not affect average performance for the group. The value, the random error value will change, it will vary, but even though it is varying, it will not affect the overall performance. That is called as what? Random error. Then next we have the systematic error. What do you mean by systematic error? Systematically. Okay, so in the sense, either the error is increasing positively or the error is decreasing negatively. Either it is increasing or it is decreasing. That is called as what? Systematic error. So types of systematic error: any factors that systematically affect measurement of the variable across the sample is called as what? Systematic error. What do you mean by systematic error here? Any factors that systematically affect measurement of the variable. So whatever the variable it is affecting, that is called as what? Systematic error. That is called as systematic error here. Okay. So the systematic error, it is a, for instance, that is asking the questions that start, do you agree with right-wing fascists that will tend to yield a systematic lower agreement rate? That is what? Systematic error. Systematic errors does after average performance for the group. It affect the average performance of the group here. That is what? Systematic error. Random error, overall performance will be same, but systematic error, it will differ. Okay, then in errors, again, we have the types like absolute error, relative error, and percentage error. How to calculate these errors? Let us see. The first one we have, that is absolute error. What do you mean by absolute error? See, for example, suppose if we have even numbers, means if randomly they have taken here, if we have numbers like a1, a2, a3, so on up to n, then the absolute error is given by, absolute error is given by, sometimes we denote it as delta A. So this delta A is equal to a1 minus A mean. So in simple words, we can understand like this. That is A1 minus A mean. Means, for example, if I take the number like 1, 2, 3, 4. These are the given numbers. How to take the mean of these numbers? Mean is taken as 1 plus 2 plus 3 plus 4 divided by 4. That is equal to 2 plus 1 is 3, 3 plus 3 is 6, 6 plus 4 is 10 by 4. So 10 by 4. So if you calculate this, you will get it as 2 point something, right? That is 2.5 you will get, right? This is what, this is the mean. This delta A means the error is given by, absolute error is given by A1. A1 is how much? It is 1 minus, then A mean is how much now? It is something, it is 2.5. Assume that. So 1 minus 2.5, whatever the answer you will get, that you need to write. No doubt here the answer you are getting in minus, but absolute errors we take it in a mod sign, which means that whatever the answer you get, that we write in terms of positive only. So absolute error is what? It is the subtraction. It is nothing but subtraction, or the difference between the given number and the mean value is called as what? Absolute error is called as absolute error. To calculate absolute error, we need to calculate the mean. So in the first line here, you can see that is, we have this, that is A mean is equal to A1 plus A2 plus A3 plus and so on up to AN divided by N. Then this absolute error is written as A mean minus A1. So if you are taking in a, what you can say, mod, then we can write it as what? Mod of A measurement or X measurement minus X accepted. Okay, so absolute error is positive, negative, or 0 also. So in simple words, we can define it as what? It is the difference between the measured value and the actual value. The difference between the measured value and the actual value is called as absolute error. Okay. So this is regarding the absolute error. Next. Then next, after absolute error, we have relative error. Relative means here the quantity is in the form of ratio. The quantity is in the form of ratio here, that is taken as what? Relative error. So relative error, how we do? Relative error is nothing but it is the ratio of absolute error of the measurement to the accepted value. Means here I'll give an example for this, then you will understand. That is, suppose again, general example we'll take A1, A2, A3, so on up to AN. These are the numbers. How to calculate the mean of this? The mean of this is written as delta A mean is equal to A1 plus A2 plus A3 plus and so on up to AN divided by N is what? Mean of the given number. This is what delta A mean. Now here we will calculate delta A of 1 is equal to, this is what? Mod of A1 minus A mean. Okay, here we will take it as A mean, not delta. A mean we will write. Delta A2 is equal to A2 minus A mean. Then delta A3 is equal to A3 minus A mean. Continue up to so on. For till up to n terms we write this one. Okay. So here what we will do, whatever the number you are getting, take the mean of that. Then the mean of this is taken as delta A mean, delta A mean. Then the ratio of this delta A mean to the A mean is known as what? Is known as what? That is relative error, is known as relative error. If you want, we'll take one example also. Suppose if we have a number 2, 4, 6. Okay, take the mean of this. So mean is, I'll write it as A mean. So A mean is equal to, it is 2 plus 4 plus 6 divided by 3. So 6 plus 4 is 10, 10 plus 2 is 12, 12 by 3. right now. Okay, so it is 12 by 3, 3 ones are 3 fours are, that is nothing but 4 is what mean. Now delta A1 is equal to, it is mod of A1 is 2 minus mean is 4, that is nothing but minus 2, but we write it as 2. Then delta A2 is equal to, it is 4 minus 4, that is equal to 0. Then delta A3 is equal to, that is 6 minus 4, that is equal to 2 again. So now you take the mean of these values. So 2 plus 2 is 4. 4 by 2 is nothing but what? It is 2. Okay, so the mean of this one, therefore, the relative error is given by, it is delta A mean how much? 2 divided by A mean is how much? 4. So 2 ones are 2 twos are, that is nothing but 1 by 2. This is called as what? Relative error. So in words what we have written, relative error is the ratio of absolute error of the measurement to the accepted. The relative error expresses the relative size of the error of the measurement in relation to the measurement itself. Okay, when the accepted or true measurements is known, the relative error is found using. So we have this formula also. Okay, so next we have the percentage error. What is percentage error here? Whatever the relative error answer you are getting. So in the given example, I got it as 1 by 2. So if I express this 1 by 2 in terms of percentage, then it is called as what? Percentage error. Then it is called as percentage error. Let us see that. Okay, next we have the percentage error. This percentage error is nothing but it is the relative error measured percentage. So the percentage error is equal to, it is mean absolute value divided by mean value into 100. So instead of all that, you can just take it as whatever the relative error answer you are getting. That is percentage error is equal to relative error into 100. Suppose in the previous example, we got it as 1 by 2 into 100, or simply we can write it as 1 by 2%. This is what? This is the percentage error. This is the percentage error. Expressing the relative error in terms of percentage is taken as percentage error. Is it clear? Next. Okay, then next we have the relative error expressed in percentage is called as what? Percentage error. The error is communicated in different mathematical operations as detailed below. So here you can see that the error is communicated in different mathematical operations. That is, x is equal to a plus or minus b. Its error is written as delta x is equal to plus or minus delta a plus delta b. Then for x is equal to ab, it is written as delta x by x is equal to plus or minus delta a by a plus delta b by b. Okay, based on this we have numericals, that is based on errors here when we have the mathematical expressions. So for x is equal to a by b, it is written as delta x by x is equal to plus or minus delta a by a plus delta b by b. Okay. So for multiplication and division, we have the same method. Then for the powers, it is written as the x is equal to a raised to n, b raised to m by c raised to d can be written as delta x by x is equal to plus or minus n into delta a by a plus m into delta b by b plus P into delta C by C. Means for last one, I'll show you the example. Remaining all it is just plus and minus and multiplication and division. So last one, for example, suppose if you have the expression something like this, that is x is equal to a raised to 2, b raised to 3 by c raised to 4. Then this error is written as delta x by x is equal to plus or minus, that is 2 into delta a by a plus 3 into delta b by b plus 4 into delta c by c. This is how we express the number. Okay, so this is regarding what? The given errors expression. So here students, this completes the synopsis parts of physical world, units and measurement. So what all we have discussed in this chapter? We discussed, so it is almost if you see the NCERT, it is a 2 chapter in one this thing. Okay, so that is what you mean by physical world. We discussed how physics and technology are related, then the fundamental forces in nature, gravitational force, electromagnetic force, strong nuclear force, weak nuclear force. What do you mean by a physical quantity? Then types of physical quantity, scalars, vectors, then fundamental and derived quantities, examples, and then next units. So different system of units we discussed. Then very important point, that is dimensional analysis and dimension, how to write it. Then applications of dimensional analysis, advantages, disadvantages, then unification and reductionism, then conservation of laws we have. After that we discuss significant figures, accuracy, precision, definition, then types of error, then how to express the error. Is it clear? So this completes the synopsis parts. So let us continue with the numerical. So the first MCQ question is, the equation P plus A divided by V square into bracket V minus B is equal to constant. The units of A is. So as we know that by using the dimensions, we can calculate the unit of a given physical quantity, right? So here, what we can do, we can calculate the unit of the given physics equation, that is P plus A by V square into bracket V minus B. How to do the unit here? Let us see. That is by using dimensional analysis method. So what we need to do here, according to the principle of dimensional homogeneity, we can write it as P is equal to A divided by V square. Okay, therefore we have, this implies A is equal to P into V square. Why I am taking this equation? Because we want the dimension of, the unit of A here. Therefore, I am taking the equation like this. Now write the dimensional formula for P. P is pressure. So pressure is having the dimensional formula M L raised to minus 1 T raised to minus 2. Then volume. Volume is having the dimensional formula L raised to 3. But as it is V square, we will take it as what? L raised to 6. That is equal to M L raised to plus 5 T raised to minus 2. Therefore, write the unit of this. Okay, if you see the options, they have given the options in terms of CGS unit. Therefore, let me take the unit in CGS. Mass is taken as grams in CGS. Then length is taken as centimeter to the power of 5 into time is taken as second raised to minus 2. Second raised to minus 2. So here gram centimeter per second square is called as gram centimeter. How we know that? The unit of Newton is what? It is kg meter per second square. In CGS unit, we write it as kg is taken as gram, meter is taken as centimeter, and time is taken as second square. So therefore, here centimeter to the power of 5 is there. I can write it as centimeter into centimeter to the power of 4. Okay, so that will give you centimeter to the power of 5 itself. Therefore, gram centimeter per second square is called as what? Dyne into what is remaining? Centimeter to the power of 4. I hope you understood this, what we did here. So P is equal to A divided by V square. Therefore, A is equal to, write the equation. Write the dimensional formula for pressure and V. So after writing, take the units in terms of CGS as the options are given in terms of CGS units. Therefore, mass is taken as gram, centimeter to the power of 5 per second square. As we know that kg meter per second square is nothing but Newton. Similarly, gram centimeter per second square is dyne. Into we are left with centimeter to the power of 4. Therefore, the correct option is option B. Dyne into centimeter to the power of 5. Dyne into centimeter to the power of 5 is the correct option. Okay. Right. Let us see the next question. Next question is x is equal to at plus bt square, where x is distance traveled by the body in kilometer while t is time in second. Then the unit of b is, how to do this one, see here. So like previous sum, we need to simplify the equation for b, write the units. The options are given in terms of kilometer and all. We need to take in terms of means SI unit itself. Okay. So therefore we can write it as x is equal to it is bt square, which is equal to, means which implies b is equal to what, x divided by t square, So therefore here x is in terms of, it is distance, therefore the distance is measured in terms of centimeter, time is measured in terms of second square. But here, as it is distance and we need to take in terms of SI unit, we will take it as what, kilometer, that is kilometer. Options are given in terms of kilometer, therefore we are taking in terms of kilometer per second square, that is option, which one, kilometer per second square, option D is the correct option. Kilometer per second square, D is the correct option here. Is it clear, students? So remaining numericals we will continue in the next class. Thank you.